Okay, in this video I'm going to continue with my series on strategies for dealing with missing data when carrying out SEM with MPLUS. My first video demonstrated the use of the listwise deletion option, but there are problems with that particular approach, not the least of which is that it can result in a large amount of data loss if you have a number of missing data points distributed over a number of variables in your model. So in this particular demonstration, I'm going to illustrate the use of full information maximum likelihood estimation. And what I have right here is a syntax file. It's actually in Word. And I'm just going to, I've already typed this up, and I'm going to just copy and paste it into MPLUS, and then we'll walk through some of the actual steps. Or actually, it's a little bit on the small side in MPLUS, so maybe what I'll do is I will just refer to the components while it's in the Word document. But you'll see, first of all, we have a title line right here, which is so the title command followed by just sort of a description of the project. We have data command, and then we have the file statement, file is, and then we have essentially the path leading to the data file. It's a CSV file that we're using. The file is called ANES space binary db.csv. So this line essentially is reading in the data file. The variable command is used to give names to the actual variables that are in the data file. As I mentioned in my previous video, the CSV file cannot contain variable names, and so we have to associate the variable names with the variables that are in the columns in the CSV file. So where we say names are, and then the names of the variables as they would appear in the CSV file. So make sure that you correctly provide the order of the variables or provide the names in the order in which they appear in the CSV file. Next we have the use variables are option, and essentially we are identifying the subset of variables that we're going to include in our analysis, because the actual CSV file has more variables than what we're going to use in our analysis. So we're going to use the use variables option to identify those variables for our analysis. If the CSV file only contained the variables that are going to be included in the analysis, then there would be no need to have the use variables option provided. So then we have missing are all 999 that's inside the parenthesis, and so basically we're just assigning a missing value code overall. And as I mentioned in the previous video, if you are converting your data from SPSS or some other program into a CSV file or DAT file, you don't want to have any missing or blank spaces. So you need to use a missing value code, and so I'm just using 999 as a missing value code in our data set. So then I lay out the model. So I've got trust in the government being regressed onto the predictors, and so we have social conservative beliefs, economically conservative beliefs, and liberal conservative political identification. So this variable right here ranges from extremely liberal to extremely conservative. It's a 1 to 7 scale. So higher values would indicate greater levels of conservative political identification. So we have libcon also being regressed onto income, socio-conservative beliefs, and economically conservative beliefs. So libcon is actually serving as a mediator, or at least a partial mediator between these variables right here, and income level and trust in government. Okay, so I also have incorporated a couple of 3 lines that are essentially comments. In MPLUS you can add comments to the syntax and not have the program read the comments or utilize them in any kind of fashion, just to provide some description. So I've got exclamation point, and I just say, to ensure that the exogenous variables are not listwise deleted, request their variances, and then I just kind of reference sort of the discussion posting where there's some discussion of this. And the strategy just basically involves estimating the variances of the social conservative beliefs, economically conservative beliefs, and income level variables. All of these are exogenous variables within the model. And so basically an exogenous variable is one that is not predicted by anything else in the model, whereas all the endogenous variables are the y variables, and they are predicted by other variables within the model. So then we have set it up as analysis command followed by estimator equals and then MLR. So instead of using ML for standard maximum likelihood, we're using MLR. Then I've also included an output command, and then I'm requesting in the output the option to obtain the standardized estimates for the model, which will provide essentially standardized path coefficients and R-square values. So there you have it. There's the basic breakdown of the of what we're going to run. So I'm just going to copy this. I guess I've already maybe done this. I'm going to paste this in and click on Run. And I'm just going to save over what I've done previously. So scrolling down, we can see there's a little bit of a warning message just because my variable names are a little long. It doesn't really matter. It's not going to have any kind of impact. It's just going to end up with some truncation of variable names. Scroll down and you'll notice that the number of observations is 4253, which is the number that was in my original, the number of cases in the original CSV file. So we'll scroll down, and you'll see the input data format was free, and as I was kind of mentioning before, you have to use a global missing value code when you are using free format data that's being input. So there you go. So scrolling down a little bit more, we get univariate sample statistics, and then you can see that we get our model fit information right here. And we have our chi-square goodness of fit test that's provided down here. You'll notice that the p-value is 0.2172, so that's greater than 0.05. So that would be consistent with a good fitting model. And then we scroll down a little bit further, and you can see the RMSEA is 0.011. And so, with the RMSEA, basically values from 0 to 0.05 are considered indicative of close fit. Between roughly 0.05 or 0.06 to 0.08 would be considered acceptable, and then above 0.08 would be considered an indicator of poor fit. So based on the RMSEA, there's evidence of good fit. When we look at the CFI and TLI, we have values of 1 for the value of 1 for the CFI, 0.999 for the TLI. Basically, values that fall above 0.90 would be considered acceptable. Values, kind of more optimal levels, we were looking at values that are greater than 0.95. So both of these are indicating good fit. And then the standardized root mean square residual, the value is 0.004. Basically, if we're below 0.05, that's going to be an indicator of good fit. So we're good there. So the model results, we have the unstandardized path coefficients for the model, and many of these are mirroring the same conclusions that we had in the previous video on list-wise deletion. So you'll notice that social conservative beliefs, economically conservative beliefs, and political identification favoring conservative identification, all those were negatively related to perceived trust in the government, and all of those predictors were statistically significant. The libcon variable, in terms of being predicted by income level, social conservative beliefs, economically conservative beliefs, we see that essentially social and economic beliefs, conservative beliefs, are positively predictive of political identification, conservative political identification. Both of those were statistically significant in the model, as you can see right here. Income level was not a significant predictor in the model. When we scroll down, we get the standardized model results. So you can see we have the standardized estimates right here for the path. We have the standard errors and actually z-values as we had above for the standardized coefficients, and then significance levels denoted right here. And then as we scroll down, you can see that we get the R-square values. So in terms of trust, the predictors accounted for about 8.4% of the variation, and libcon the predictors accounted for about 53.5% of the variance. To look at our path diagram, we'll just go to View Diagram, and there it is. And so, as you can see, these are all unstandardized path coefficients. If I want to look at the standardized path coefficients and their standard errors, which are appearing in the parentheses, we just go to this button right here, and there you go. So now we have the standardized path coefficients and their standard errors. So that concludes this video demonstration.